Okay, so the big deal is, so first off, obviously this would need to be a flat, linear. You would need to have the ability to make hydrogen bonds on both sides for it to be that beta sheet, right? So we look at these things, and you're going to have this hydrogen bonding. First off, hopefully you guys recognize they're flat. They're making the hydrogen bondings across, right? These are some form of beta sheets, right? Can you see this one as well? Has that flat zigzag structure with the R's facing opposite directions each time. See that? Doesn't make any helix or anything. And it makes the hydrogen bonds in between the amine and carboxylic acid groups, right? Okay. Is everybody good with that so far? Well, the carboxylic acids in this case would be the oxygens. It doesn't have the other oxygen anymore, right? Because this is the peptides. So first off, let's do the easiest one. We don't have the other group, so we have no idea which type this is, right? Is it parallel, anti-parallel? Who knows? We don't know what the other group looks like. So this could be either, right? It still has that same zigzag pattern as all the other ones do, right? So this could be one of these things in any of these, right? There we go. So that makes sense. Either. So what's the difference between anti-parallel and parallel? Exactly. They're going to be nice, beautiful, like almost right angle looking, right? Very straight, very synced. The other thing is the top one here would be an oxygen. The bottom one would then be a nitrogen, right? Because they're going to alternate. See that? And why is that? Because they're going opposite directions, right? Where one's nitrogen is, the other one's oxygen is. Where one's oxygen is, the other one's nitrogen is, right? And so you literally can just go down the chain and go, you know, oxygen, nitrogen, nitrogen, oxygen. See that? They're opposites. So they have to be opposite of parallel, right? Okay. This one here, they're same, aren't they? Oxygen, oxygen, nitrogen, nitrogen, oxygen, oxygen. See that? You guys see how they're lined up? So they're parallel, aren't they? So that has to be parallel beta sheet. We go on to the next one. Well, this one's even easier to see, isn't it? Oxygens, nitrogens, oxygens, nitrogens, oxygens. They match up really beautifully. So that one's very easy to see how they're parallel, isn't it? They literally are the definition of parallel. This one actually does a pretty good job of showing you how they're the exact opposite of parallel, right? You see that they match up the exact opposite group. Okay. Okay, so everybody's good for those so far, right? Okay, very good. This one would be the final one. Let me ask you this question. Did anybody notice what the R groups always do in these? What happens to these R groups? They switch sides, opposite sides every time, right? And that's because they have to, see that? Towards us, away, towards us, away. Why is that? Because they have to be alternating in that zigzag structure, right? Or else they wouldn't line up. Okay? What's this one like? Yeah, it's all on the same side, right? And so this one cannot be any type of beta sheet, right? Not in the way it's presented here. It would have to completely rearrange to make that alternating R groups, right? Anybody understand? Does everybody understand why it has to alternate? So you need the nitrogen and oxygen to make hydrogen bonds. If the R groups don't alternate, you'll never have the nitrogen and oxygens that can come together. Can you see that okay? Like, imagine if you flip this nitrogen would be over here, wouldn't it? the oxygen right here would be over here if you flip this R group. And so it couldn't make the hydrogen bonds. Okay. Yeah, almost really, biochemistry is the application of just simple deductive reasoning to what you already know from organic and general chemistry. Okay? That's pretty much what it is. And cell biology and all those, the biology classes. There's a little bit of biology. Did anybody need anything else on that?